All right, this is the 6th video, Refraction of Light Labs Part A from air to water. We've got our data here in our chart. We've already calculated the sines of our angles and calculated the ratio of our sines of our angles. So we're going to look at this data here, and just to kind of simplify it a little bit, what we're going to do is we're going to round each of our values to one decimal place. Now we've got a value of 2.0 here, so obviously if we round it's still 2, but this, if you look at the data, 1.52, 1.46, 1.52, 1.45, 1.47, 2 is kind of, you know, out of place here, so there's probably a source of error that's causing that particular value there. So let's just focus on the remaining values. So if we round each of these, it becomes 1.5, 1.5, 1.5, 1.5, and 1.5. Wow, look at that. We've got all the same values. The sines of the incident ray over the sine of the refracted ray all gave us essentially the same value. Okay, so that's pretty interesting. If we look at what happened to the light when we sent it along the normal, so our angle of refraction, our angle of incidence was 0 degrees. We've got an angle of refraction of 0 degrees. So that means at 0 degrees, the light will pass straight through and not refract at all. If you look at the angles of incidence and compare them to the angles of refraction, you can see that all the angles of refraction are less compared to the angles of incidence. So that means that light will actually bend towards the normal and decrease the angle of refraction when you compare it to the angle of incidence. Okay. Now these values here of 1.5 indicate that our prism here, okay, has an index of refraction of 1.5. And if we were to look that up for glass, I don't know if this is actually a pure glass. It's probably some mixture of glass and some other polymer. Then we should get a value that is very close to 1.5. Okay, so that just means that the material that makes up this particular prism is slowing down the light the same amount no matter what the angle of the light coming into the prism actually is. Okay.